Hey guys, it's Mr. Marone. Welcome back. I just want to give you a quick refresher on classifying triangles before we go on our 4-day break and before we get really into the congruent triangles section that we're getting into in the next couple weeks. So we're going to take a look at classifying triangles by two different methods, by angles and then by sides. So if we start with classifying triangles by angles, we have four different options. Okay, if a triangle has three acute angles, if all the angles are less than 90 degrees, then we would call that an acute triangle. Okay? If we have one obtuse angle, as you can see right here is our obtuse angle, we would call this an obtuse triangle. And we can only have one obtuse angle in a triangle, so that automatically makes it an obtuse triangle. If we have one right angle, as indicated by our normal box in the corner, we would call that a right triangle, as you guys have well seen. And then if there are three congruent angles, we refer to that as equiangular, meaning of equal angles. So Equiangular, equiangular. Okay, so keep in mind those four as we go on to our example here, trying to classify these by their angles. So if we look here, we want only the angle measures. Okay, so you have to really dissect the picture here. And I'll do the first two, and then I'm going to let you guys do the next three on your own, and I'll pause the video. So CDE is this triangle right here. It's clear that at angle E, we've got a right angle. So that means that triangle CDE would be a right triangle. And we use the little triangle to just indicate that. Now, if we're to look at triangle BCE, this triangle right here, we see that angle C is an obtuse angle. Okay, it's our one obtuse angle, so this would give us an obtuse triangle. Okay. So I'm going to pause for a second and let you guys try 3, 4, and 5. So hit pause on your YouTube video and try to fill out 3, 4, and 5. And when you come back, all three of them will be filled in. All right, welcome back. So as you see, triangle ABE is equiangular because there are three congruent angle marks. Triangle CFE in number 5 is an acute triangle. They're all acute angles. And then an obtuse triangle in number 4 is key because if we look at angle E from this triangle BDE, okay, E is a collection of these three angles, which makes it an obtuse triangle. So just keep that in mind as you look through here. One thing I do want to point out is that every triangle has a measure of 180 degrees inside of it. So when we have an equiangular triangle, as we had in number 3, each of the angles are going to measure exactly 60 degrees. So just keep that in mind as we move forward. Next, we're going to take a look at classifying triangles by their sides. Okay, there's only 3 classifications here. If we have 3 congruent sides, that is called an equilateral triangle. Equilateral. So just like the equiangular meant equal angles, equilateral means equal lines. If we have 2 congruent sides, we refer to this as an isosceles triangle. ISOSCELES. Kind of a tough one to spell. We have an isosceles triangle. Okay? And if there are no congruent sides, if they're all 3 different measures, we would call that a scalene. SCALENE. A scalene triangle. Okay, so keep that in mind as we move to our next slide here. So using that information, they want you to classify these 3 triangles. Okay, JKM here has all 3 different sides, so we would call that a scalene. Triangle KLN in here, we notice that they have 2 tick marks on 2 of the sides, which would indicate it is an isosceles. I removed everything there so you could see what we were talking about in regards to an isosceles triangle. Sides KL and LN are both the same measure indicated on the picture. And finally, triangle JKN, right here, sorry for the scribbles, all 3 sides have 1 tick mark, which would indicate to me that it is an equilateral. Right, so we have a scalene, an isosceles, and an equilateral triangle. Now, at the bottom of your page, they gave you 6 triangles here. And they want you to classify each by its angles and its sides. So if we looked at number 9 together, and then I will stop and let you guys try to figure them out, and then fill them in once you come back. So once again, you'll pause. But looking at number 9, if we classify it by its angles, you see here they gave us that right angle mark. So this would be a right triangle. And they also gave us 2 tick marks on 2 of the sides, which would indicate it is isosceles. Sorry for the spelling error there. So this would be a right isosceles triangle. Right? Now, for number 10, they gave us a 114-degree angle, which is obtuse. And although these sides on the bottom and the right look about the same, they haven't given us any indication in regards to congruence marks or measures. So we don't know anything about it, and therefore we have to think it is a scalene triangle. So we have an obtuse scalene triangle. At this point, I'm going to invite you to pause the video and try each of these 11 through 14 on your own, and then when you come back, they will be filled in. Alright, so take a look at 11 through 14. I got an equilateral and an equiangular triangle in number 11. All 3 sides and all 3 angles are the same. And just as a little added bonus, this would be known as a regular triangle. Anytime there's a triangle with 3 60-degree angles and all 3 sides are the same measure, it would be considered a regular figure, which we'll talk about much later in the year. Number 12, I had acute scalene because they gave us no angle representation there. Number 13, they gave us a right angle and nothing else, so it's a right scalene. And in 14, they gave us 2 side measures of 5, which told me it was a isosceles, not a scalene. Mr. Rowan messed up. So it is an isosceles triangle, but it is also obtuse. So I'll invite you to take a look through this again. Make sure you feel comfortable with this, and take a look at pages 2 and 3 in your notes packet over the 4-day break and see if you can solve those problems. And we will talk about them when you get back from Thanksgiving break. Have a happy Thanksgiving, everybody.